Hi guys, Hoffbauer here. Hopefully yesterday we knocked out most of ellipses, so today we're just going to finish up a couple quick things that we might have run out of time for yesterday. I'm recording this before we've even had that lesson, so I hope I'm doing the right thing here, but hopefully you have out your unit circle sheet, or I'm sorry, your reference sheet on conics. This is a super important little box over here that reminds you the difference between an ellipse equation and a hyperbola equation. The first difference is if it's a hyperbola, it's minus in here. If it's an ellipse, it's plus. But the other thing is that for a hyperbola, the a squared is always under that first term, and the minus is here, and the b squared is always at the back. But for an ellipse, a squared could be either of these places because it's simply the bigger value, okay? So whichever is bigger of the a squared and b squared tells you which direction you're going to go further in, okay? So let's get to... It says we maybe skipped this one on the notes, so quickly just reviewing what this is all about. Under the x is a 9, so the square root of that is 3. We go 3 each way. Under the y is a 7 squared, so we go 7 each way. And I should have mentioned because there's no minus h or minus k on the top, we're just centered at the origin. So, ooh, there's badly drawn, really badly drawn ellipse. But the other thing you have to do, you would name these the vertices up here at 7. Let's see, we want to cross 0 and up or down 7. That would be the vertices. And the co-vertices out here would be at plus or minus 3, 0. And the only other thing you have to do is the foci, and those, remember, there's a different equation. When it's an ellipse, it's c squared equals a squared minus b squared, and that's so that they go inside of the ellipse instead of outside. So if we did a, which this one was a squared and this one was b squared because a, remember, is the greater one, so we'd have 49 minus 9 is 40. So you could do square root of 40, and they would be on the longer axis here. Square root of 40 is 6 point something, so they'd be really far out here on the ends. But I'm really okay if you simply told me 0 plus or minus square root of 40. If you want to rationalize, that'd be great, but I'm not going to be picky about it. You could even give me decimals. So square root of 40 is 4 times 10, so 2 square roots of 10. Or whatever that decimal was, which is 6 point something. Anyway. All right. I'm going to skip that one. I'm not sure. I'll go through this one kind of quick because I feel like this one, I don't know how many we're going to get through the first day we do this, so I'll throw this in. You can always fast forward if you don't need it. On this one, h is -1. K is 3. Down here, this would be b squared, and this would be a squared because it's the bigger one, okay? A is greater than b for these, okay? So, let's see, we'd have a is 4, b is 3, c squared equals a squared minus b squared. So a squared was 16, b squared was 9, so that is 7. So c is the square root of 7. All right, I'm going to kind of do this conceptually, and then we can talk about following the recipes if you want. X, the center, the center is at hk, or -1, 3. -1, 3. And then underneath the y was a 4 squared, so we're going to go up and down in the y direction 4. And we're going to go in the x direction 3, because that's what was under the x term. So this one's almost a circle. It's a little longer up and down than it is side to side. So the foci are on this axis that's going up and down. It's called the major axis in this picture. The vertices are also at the end of that, so they are, you can follow the recipe, but it is going to say, let me see, I'll grab my sheet so I don't write it down wrong. For one that is longer up and down, the vertices are at h, comma, k plus or minus a. So we'd have -1, comma 3 plus or minus 4, which puts them up at -1, 7, 3 plus 4, or down at -1, -1, 3 minus 4. All right, then we need the co-vertices out here on the end, and those are left and right. So the formulas for those are h plus or minus b, comma k. So we have -1 plus or minus 3, comma 4. Nope, 3, comma 3, sorry. So that would become -1 plus 3 would be 2, 3. And -1 minus 3 would be -4, 3. I hope that's where I have them. -4, 3, and 2, 3. Yep, that looks good. Only other thing you have to do on a quiz is find the foci, and those are square root of 7, the away from the center here, and the square root of 7. So you would be able to just write on the quiz the formula, which is h, or -1, comma, k plus c, which would be 3, plus or minus the square root of 7. Just so that I can graph them halfway accurately, square root of 7 is a little less than 3, so it'd be almost to 6 here, and down here, 1, 2, almost 3 units. So they're a little ways inside. The further they are inside, the more round the parabola is, or the ellipse, sorry. All right, this is what the point of the lesson is today, is that I think we didn't get to these on the day we talked about ellipses. So we're going to just talk about this when you have to write an equation. So this one is centered at the origin. So there's our center. And it says that there's an x-intercept at 6. And so there would also be an x-intercept at -6. Now it doesn't tell us if those are the ends of the major axis or not. The focus point also on this axis, oh, no, it's not. Look at that. The foci are at 2 square roots of 7. Now, I don't know where my calculator is. Here it is. All right. 2 square roots of 7 is about 5.29. So up here at 5.29, or 2 square roots of 7, are the foci, but the major axis is where the foci lie, so we got to be further out here. All right, anyway, this is what we're going to do. If the center's at the origin, we have an x squared and a y squared, and it's a plus because it's an ellipse, okay? In the x direction, we went 6 either way, so under here is a 36. Now, I'm positive that because the focus was on this axis, that we're going to get a bigger number under here. So I'm going to call this b squared. Nope, I'm going to call this a squared. Just kidding, because it's going to be bigger than this one. And so we'd have, the formula is c squared equals a squared minus b squared for an ellipse. So we would have 2 square roots of 7, that's our c value, squared equals a squared minus 36. So let's see how this all works out. 2 squared is 4, square root of 7 squared is just 7, so that becomes a 28 equals a squared minus 36. So if we add 36 over here, what do you know? We get 64, which sounds like a really nice perfect square to be a squared. So all we're going to do is replace that with a 64. which means that we were out at 8 either way here, and here would be down at -8. So if we wanted to check that, we'd have 64 minus 36 as our A and B, and that would give us 28. And when we square rooted 28, we'd get 4 times 7, or 2 square roots of 7 for the foci. So we're double checking that that works. Okay? But I always have to start with a sketch on these because I can't keep straight in my head. You can try to follow just by doing the recipes, but it's easier for me if I do a little sketch. So one more of these. There's a y-intercept way down here at -9, so there'd be one, since it's at the origin, that's important. The other one would be up here at +9. And the foci are at 0, 6 square roots of 2. Let me type that in. That's about 8.5. So I think this is going to be narrow because they're just inside of here. But they are on the major axis with that 9, which happens to be the y-axis. So I think we're going to have a number here and here that will give us our x-intercepts. So because the y-intercept, mostly because the focus is on the y-axis, okay? Let me talk about it this way. On the sheet, right now, because the center is at 0, 0, we have h and k are both 0. And on the sheet, when the foci are at h, k plus or minus c, it means it's longer this way. Okay, so that's helping us know that it's this way. So we know that h and k were both 0, so this is c. I'm trying to do this more recipe-ish for some of you. Okay, and this then becomes a vertice, and the formula for vertices is h, k plus or minus a, and a is going to be 9 because h and k were 0. All right, knowing all this, my formula says x minus h squared plus y minus k squared equals 1. And this guy is going to be over b squared. And this guy is going to be over a squared. But we just figured out that a was 9. So this is going to be 9 squared, or 81. All right. So we got one more thing to find. We got to figure out b. So c squared equals a squared minus b squared. C squared is 6 square roots of 2 squared. A squared we know is 81, or 9 squared. And we don't know b squared. All right, this is 81. 6 squared is 36, square root of 2 squared is 2, so I have 72 equals 81 minus b squared. Well, I could subtract 81 and I get -9 equals b squared. I divide them both by -1 and I get b squared equals 9, or b is 3. If I wanted to draw this accurately, this would be -3 and this would be 3. But the bottom line is that b squared was 9 after we squared it, and this one was 81. So we ended up with x squared over 9 plus y squared over 81 equals 1. And then you could find c and double check that it was 6 square roots of 2 if you really wanted to. All right, I'm going to do these. We probably already did them. I'm going to go through one more time. Just if you want to skip this part, it's up to you. But you put the x's together, you put the y's together, you move the constant over to the other side, you factor out the coefficient, and put in a blank. You factor out the coefficient on y squared, carefully, and then you put 2 blanks over here. All right, and then we have a 4 And when we take half of this, we get x minus 10. And we square it and we get 100. But remember, what we really added there is 4 times 100, or 400. Then back here we have plus 25. And we take half of this b, which would be plus 1. And we put it back up here and we get a 1. But what we really added is 25 times 1. So this turns out to be 400. Then we have to make it equal 1 because that's what they look like. So we divide everything by 400. And we get x minus 10 squared. 4 goes into 400 and reduces 100 down here. 25 goes into 400. I want to say 16, but I'll check. 400 divided by 25 goes in 16 times. And this was a y plus 1. And 400 over 400 is 1. Now, what I have reassured you is that these should both be perfect squares. If they're not, if it's not coming out nice, then you made a mistake somewhere. And the first place to look are sign mistakes when you factored or when you added over to this side, okay? Or when you moved the 25 over to this side. Sometimes people forget that guy. All right, I'll run through this super fast. I think I'm not even going to talk. How's that? Ooh, 56 divided by 4. I'm talking because I can't do that in my head. 16 maybe? 14, just kidding. And with the y's, we're taking out a 9. Move the 97 over, it's going to be negative. So this would be a 4 and an x plus 7. Half of this squared is 49. And then 4 49s go over here. And then we have a 9. Half of this would be 5. Put it in here is a 25. So we have 9 times 25. So we had a negative 97. Whoops, that's not where I want to be. Negative 97 plus 9 25s. I remember that, I think. Plus, what was the other one? 4 49s. 4 times 49. Okay, I got 324. So I'm going to divide everything by 324. And I'm going to have equals 1. Now, 9 divided by 324, math enter, enter, reduces to 1/36. And 4 into 324 goes 81 times. So again, we wound up with perfect squares down here, okay? All right, I hope you got it. The assignment is to finish up worksheet 7. I think you have maybe 2 questions left to do. And then to work today on worksheet 8, which is circles and ellipses. And there's like 8 or 9 or 10 questions on worksheet 8 you need to finish up. So you might have a little homework. I know I said there wouldn't be homework this week, but we didn't get as far as I wanted, so I apologize if you have a tiny bit of homework, but hopefully you can get stuff done in class.